Our last 2.0 objective is simplifying square roots. These questions are off of your review. First question, number 5, is -3 root 5 times 4 root 7. When you're multiplying radicals together, you can only multiply the parts that are on the outside and the parts that are on the inside. So we're going to start by multiplying -3 times 4. And it's going to stay on the outside of the square root. And then we're going to multiply the square root of 5 times the square root of 7. To know whether or not we're done, we have to check a few things. There is not a square root in our denominator, and 35 is not divisible by any perfect square other than 1, so we are done simplifying. In this question, the quotient property of square root says that we can rewrite this as the square root of 2 over the square root of 7. And when we do that, we see that we have a square root in our denominator, which means that we are not done simplifying. We have to do what's called rationalizing the denominator. Since square root of 7 does not give us an integer, we are going to have to multiply on top and bottom by the square root of 7. When we do that on top, we have square root of 2 times square root of 7, which is square root of 14. On bottom, square root of 7 times square root of 7 is square root of 49, which is 7. I often just skip writing the square root of 49 and go straight to 7. Now we've gotten rid of the square root in our denominator, and 14 is not divisible by any perfect square other than 1, so that means that we are done. When we are simplifying radicals, there's a few things that you want to remember. In order to be considered simplified, you can have no radicals in the denominator. You also, your radicand, which is the number underneath the square root symbol, cannot be divisible by any perfect square other than 1. And that's pretty much all you need to know at the 2.0 level. Remember, when you are multiplying radicals, multiply the things on the outside together and the things on the inside. And when you are dividing radicals, you have to rationalize the denominator.